welcome to Code Club. We're going to do our usual thing of taking some Go code, reading it as a group, trying to figure out what the code says, and maybe something about why it says that. What we're looking at this week was suggested by Tom because he's used this library recently for producing some adorable charts. And that's basically the aim of this is if you have some data and you want to draw nice diagrams of it, you can do simple bar charts, and you can also do some fancier stuff, and there's some nice examples in the README here, including animations, which is cool. And Tom, do you want to maybe say a word or two about what you wanted this for and how you came across this?
Sure. I have a little kind of side project, work side project that kind of takes in some data about the usage of our applications, and I knew I wanted to serve it in some way, but I also thought, is there an interesting or easy way to display data? And for me, it's just a line chart. I just need to know. I just want to show, over time, how does usage grow or not grow?
Yeah. And managers love a nice graph, don't they?
Yeah, it was pretty straightforward and easy to use, although there were some things in the source code that were new to me. I had to ask John about.
Right, yeah, we mentioned one or two of those. So I'm going to close this README because it's killing my machine. Okay. So, where do you think we should start, Tom, in looking at this code? Because you've looked into it more than I have.
I mean, I think where you are is not a bad spot. For me, I looked at line.go because I knew I wanted a line graph.
Right.
So I looked at that in the README, and that's most of what I needed to get.
Yeah, so we've got.
Figured out.
So I just kind of dived in and thought, okay, we have a charts thing, and I see different types of charts here. So the first one is bar. So I think I know what a bar chart is. Let's see if they have the same idea. So Tom, perhaps you do us the honour of starting to read through this, and we'll just see if we can make sense of what we find.
Sure. So we're starting with defining what a bar is. We have a bar struct.
Yeah, Goland hid my imports here, so let's just see what we're importing.
It's like just other pieces of the library or other pieces of this code base. Just a fair warning for anybody who tries to use this. When I first did my imports, the V2's got to be there. It doesn't work the same in V1.
Yeah. So this is one of these things in the era of Go modules that we've got to be careful about, isn't it?
Absolutely.
As library authors, most of us probably don't get to V2 all that often. But if we do, we've got to be aware that it will be a new import path, because as far as Go is concerned, it's a new library, and that's fair enough. Because V2, by definition, breaks code that references V1, doesn't it?
Yep. Okay, so inside of our bar, we have a rect chart. This was the thing primarily that confused me. It is an unnamed field. So rect chart is a type in and of itself. We also have another field for is XY reversal. It's a Boolean. Not entirely sure what that does, although I could guess.
Right. Anybody else seen this kind of construct before? A struct field with no name. Is that familiar to anybody?
I have seen, John. I was reading a book. It is not published yet. In my company, there is a distinguished engineer who is about to publish a book. I got a chance to read his draft where he created a user-defined struct and defined them in another struct.
And does anybody know what effect this has? I mean, why would we do something like this? First of all, what does it mean to not give a struct field a name? And second of all, why would we even do that?
Well, it's exportable if I'm correct, right? So would it be to run methods from the bar struct on this rect chart that could possibly be another struct? What type is this?
Yeah, you got it. That's basically what's happening here. Is rect chart is another kind of struct. So what happens? Suppose we did name this field. Call it RC or something, and then imagine we have a value of type bar. We want to call some methods on it, like draw or something. Maybe I don't know what the methods actually are. You know, say we had b is a bar, and we might write b dot rc dot draw, right?
Yes.
But if we leave the name out, then technically this is called embedding the struct. So rect chart becomes embedded in bar, and what happens is rect chart's methods get promoted to bar, so we can call them on bar directly. So we could say b.draw.
Kind of importing a module to the init, I think, or to using underscore, don't remember, but there is a way to import modules like that, right? You don't need to type the module name, the same we saw this week.
Effectively, yeah, it's less typing, but also I suppose another advantage is from the user's point of view, they don't need to know that this is actually a kind of a rect chart or whatever. Maybe there are multiple things which embed rect chart and we can treat them all the same way. But then they have some special extra behavior themselves. So if you're familiar with object-oriented programming, you know, like in Java, where you have inheritance, people often design hierarchies of types like this, don't they? That they say, you know, maybe you have a shape type, and then a subclass of that is rectangle, or maybe, you know, maybe polygon is a subclass, and then rectangle is a subclass of polygon, and you can effectively inherit behavior from parent classes. Well, I've got bad news for you. You can't do that in Go. So there's none of that. On the plus side, it means it's somewhat easier to figure out how our Go objects are behaving, because we don't have to search through a hierarchy of parent classes to work out where is this behavior actually coming from, which can be quite difficult. So
unless they do this, right?
Yeah, which I have to say I'm not a super fan of, but for all I know there are very solid reasons why they do it this way. But let's see how far we can get and figure out. But if you're puzzled, and for viewers at home, you know, if you're looking at that thinking, what's this even about? That's what it is. So
it makes me wonder if this library wasn't either essentially there was another library, say in an object-oriented language, that does all of this stuff exactly, and they're essentially trying to reproduce the same format.
I think it might be absolutely...
It doesn't read like code generation, but it does read kind of like, hey, I built this thing, a bar is a rect chart is another thing, et cetera, et cetera.
I think you might be dead right. I think I might have read in the README, didn't this come from Baidu originally?
That's what I get for not reading the README very closely.
Yeah, well, I won't open it again because it will crash Goland. But I think that's what it was. So yeah, you're probably right that it came from some other language which does have inheritance, and maybe this is a way to represent that in Go. And it's you know, we were talking about this earlier in saying that it's a great idea to read as wide a range of Go code as you can, to see this kind of thing. If you just read the standard library, that would be fun. There's a lot of interesting stuff in there. But of course it's written by a fairly small group of people, and a very long time ago, most of it. So it represents, one style of Go programming. It's nice to see as many different styles as possible, and you can start to make up your own mind about, I like this way of doing it, I don't like that way of doing it. Start to form your own style.
There is one other thing I noticed while reading this embedded is when we, for example, if the embedded struct here rect chart has the same name is XY reversal inside that, then when we are calling that from the bar, we have to use that like bar dot rect chart dot is XY reverse.
Yeah, that's a great point. So this method promotion thing can only work if the methods on rectchart have different names to the ones on bar, because if we have one with the same name, I think Go is probably just going to refuse to compile that. I'd have to check that, but there's no way for it to know at runtime basically which one you meant. So what we're saying here is that if it's unambiguous for you to call a method on this embedded struct, then you can, but ambiguity would be a problem. So the method sets have to be disjoint. That's one way to say that. Let's look at some of these methods then. So it looks like, so we have a method on the type itself kind of thing, which is interesting. Has anybody seen this sort of construct before? Anybody know what this means or can guess?
Is it a method defined on top of the struct where the method called type is available only for the bar struct?
Well, you know what this is? It's actually nothing special whatsoever. This is just a regular method, except that we didn't give a name to the receiver. So if you don't know what a method is, that's nothing special either. It's just a regular function, except when you have a function whose job it is to modify some object, and we would have to pass that object in as a parameter. And if you have dozens of those things, it would be kind of convenient to have a syntax where you can just say, yeah, the object, like here for example, the object is so important that we pass it in as a kind of special magic parameter that we call the receiver. And then it takes some other regular parameters. But this is basically exactly equivalent to just writing a function called setX-axis, which takes a bar as its first argument. So inside that method, we can use this name to refer to the receiver. So here this method is about setting something on the struct. So naturally we need the name of the struct so that we have something to set. But here we didn't bother to specify a name, and the reason is basically we don't need it. We never access anything about the value itself, so there doesn't even need to be a value. So you can call this method safely on nil.
And so Go, for a receiver function, Go doesn't require an anonymous representation. You can just give it the type.
Yeah, exactly. You can call methods on nil, which is sometimes handy because sometimes your object exists only to have methods. It has no. It would be a struct with no fields at all. And if you've ever seen this in Go code, somebody defines a type as an empty struct. You think, what's that about?
I've seen this in Go code.
Right.
The ticketing system.
Interesting. Yeah. So this is one of your projects, isn't it?
Yes.
What is the use of empty struct, John?
Well, this is the thing. So you might say there's no use at all because I can't store anything in it. And sometimes that's okay because maybe we're just using an empty struct as a value to pass on a channel, for example, in which case the fact that there's a value at all is the message. It doesn't have to contain anything, it's just the fact that I sent you anything is the signal. But with methods, what we're really doing is we're saying it would be nice to have a thing that we can call methods on, and maybe that object has some internal state, maybe it doesn't. If it doesn't have internal state, then there don't need to be any fields on the struct because there's nothing to put in them. And in fact, what we would have is just a type which has behavior. That is to say, we can call a method on it to get a certain behavior. And this type has some state, so it knows, it has some configuration stuff about the chart. It knows what kind of chart it is and so forth. And some of the methods that we call on it will refer to that state or modify it, and some don't. So this one doesn't need to. It just returns what is chart bar. It's just a string that says bar. So I'm guessing, Tom, you can maybe confirm this. Each one of these different chart types has a type method that you can call, and it will give you a string representing the name of the chart. That sounds believable, doesn't it?
Yeah, I mean, that's been I've only really worked with Line, but Line has the same thing.
Yeah, let's have a look.
I've yet to see,
Yep,
again, presumably when you're building a whole bunch of different, like you might want to build a bunch of different types of charts and use them, in some kind of switch statement or something. This would be useful if you're going to pass in, particularly since you're, they may be wanting to pass around. They kind of seem to want to define this thing in such a way that they could pass around some, or try to anonymize what the types are a little bit.
Yeah, maybe. And we can see here that line is a similar idea. It's just a struct that embeds an anonymous rect chart. But, of course, a line chart is different to a bar chart. And the difference will be precisely in the way that it renders it, for example. So let's just go back to bar.
Just I'm sure it's going to be a dumb question, but I don't understand why the new bar is using a different function signature. Like, why he's not passing the bar as a receiver?
Well, there are no dumb questions. Or actually, there are dumb questions. We all know that. That wasn't one of them. But I like to think this is a safe space for dumb questions, and I'm quite likely to ask some myself. So, what happens at Code Club stays at Code Club, right?
and YouTube.
Okay, so your question was in the new bar constructor. Why doesn't that take a bar? Is that what you're asking?
Why there is no receiver like in the other functions?
Right, yes, because this is not a method. So you correctly spotted that not having a receiver makes this just a regular old function.
Okay.
It returns a bar as you might expect, and it's clearly, it's a Go convention, but you don't even need to know that to guess that this would create a bar for you, and it returns a pointer to the bar. And that's interesting, as we might say, why doesn't it just return a bar? But we can see it creates a literal of that struct with nothing in it, and does some initialization on it, sets a renderer, and it says yes, it has an XY axis, and then it returns the thing.
Right.
And it's really common to see a setup like this. So most Go programs are based around some struct type that has a bunch of methods. Right, sounds quite a sweeping statement, but I'm prepared to defend this. We can open up a bunch of code from GitHub if you like, but I guarantee you'll find some struct types in there, and they'll probably have methods on. A lot of them might not even have fields. So this is really common. So what we normally do is we'll declare our type. It's a struct. It has or doesn't have fields, and then we want some way to create one. Now maybe we don't even need a constructor at all. Right, for a simple struct, maybe we just say you create it, as the user you want one of these, just make a struct literal with the curly braces like this. You can set whatever fields are exported, that is to say publicly available. And that's maybe all you need to do. But maybe, as Now we're the library author again. Maybe there's some private internal initialization that we want to do that we don't want to expose to users. No user serviceable parts inside, right? Do not open. Opening the struct invalidates your warranty. That type of thing. So the init-based configuration is going to be something like this. That's not exported, as you can see, because it doesn't start with a capital I. So users would not be able to call that. So they can create a bar because that type is exported, but they can't initialize it.
Gotcha.
We can. So by having this function, we're sending the signal saying, hey, don't just start creating your own bars and doing stuff because they won't work properly. What you need to do is call this, and I will give you an officially sanctioned bar for you to use.
Yeah, that makes sense. Since you don't have the structure yet, you can't pass a receiver because you're creating that.
Yeah, exactly. And then having got one from calling new bar, now we can start calling some things on it. And so this is the normal way to lay these things out, is first the type, then the constructor, then the methods.
I see. Thank you.
No problem. So I mentioned that it returns a pointer. Anyone like to speculate about why that is? Because there's definitely a fun topic in Go, is pointers and methods. And the book I'm working on right now is basically about pointers and methods in Go, so it's close to my heart.
I get confused whenever I read this, John. When to use a pointer and when to not to use.
Yeah, well, you can feel good because you're not alone. I think everybody is slightly confused by this.
Is this saying, well, I believe this is saying, create a new bar and return a pointer to a bar so that you're just not any bar to the bar that I have defined as type.
Yeah, that's exactly right. So let's think about it from the other end. So think about it from the point of view of a method. We can see this, the receiver of this method is not a bar, it's a pointer to bar. So suppose it wasn't, suppose it just takes a bar, and that somebody has a bar value and they call set x-axis on it. Don't really know what that does, but it doesn't matter. What the method does is it's going to basically set one of these struct fields. And in fact this field must be promoted from the rect chart type because we don't see it listed here. So again, that field must be promoted just like the methods are. So it's going to set that to x, which is what was passed in, and then it returns it, which is fine. Now we know that in Go, function parameters are passed by value. That is to say, set x-axis receives a copy of whatever's passed into it. So this C, for example, is not the original bar value, it's a copy of it. So we can modify its fields all we like here, but that has no effect on the original one. It's just modifying our local copy. And if the job of the method is to modify the original object, which it usually is, it must take a pointer, mustn't it? Because otherwise we'd be changing our copy instead of the original. Passing a pointer effectively gives you a handle on the original, and it's saying, it's like, you give your teenage son the keys to your car. It's like, there you go. You can modify the original car, but please don't. Please bring it back in roughly the same shape it's in now.
But just another question. If you receive an object and modify it and returns it, and the function calling this method could receive the value and work with a new app, but it's unnecessary, right? Why we are going to have all this memory allocation?
Yeah, well, for example, Quinn and I were talking about this earlier on, in that if you have a method on something, should you make it a pointer method so that it modifies the original and then you don't need to return anything, except maybe error? Or could it be a value method and maybe you just return the modified object? So this is a design decision for you, basically, as the library author. Do I want people to have to modify their original values, or you know, depending on what it is, maybe I need to preserve that and I don't want some method that I call to be monkeying around with it. I need to keep that pristine. So therefore, please create a modified copy and then I can do something else with that.
But I'm not entirely sure why it's returning the pointer if it's like modified already.
Yeah, well, that's it. So basically, you know, they're kind of having it both ways here. It's a pointer method and it's returning the modified object. I guess one reason for that is it leaves it up to the user which they want to do. They can either say, yeah, I'm happy to modify my bar chart, just I'll ignore the return value or whatever. Or maybe they're saying, no, I want to keep that as it is, so I will probably copy it and call the method on a copy, and then it returns the modified value. So at the end of that long shaggy dog story, the point is, by returning a pointer here, we are returning something that you can call a pointer method on. So if we just return bar, then the user would get a bar value, and they'd then have to take the address of that to get a pointer to bar, and then they'd call the method on the pointer to bar, which is what this is.
And this way you can have several instantiation of bar changing the same structure.
Yeah, exactly. And it's not like you couldn't return a value instead of a pointer, but if most of your methods are pointer methods, because they modify the object, which they usually do, so they usually are pointer methods, so it usually makes sense to return a pointer from your constructor, but it's not essential. It's just, it's kind of sending a message that, you know, expect to find a bunch of pointer methods on this. So, you know, Rakesh, if you feel confused about this when you're writing your own Go code and thinking, should this be a pointer or not? It's not as big a deal as you might think, because basically whichever it is, you can always turn it into the other. If you have a value, you can use ampersand to create a pointer from it, or if you have the pointer, you can use star to dereference it and get the value it points to. It's just a question of what's more convenient.
Makes sense.
Basically, this is another argument for doing things test first, which most of you probably don't need, but if you're writing the test before you're writing this code, then you already know that it's going to make more sense to you to get a pointer or whatever, and so you kind of design it from the other end. Whereas if we just sat down and started writing this code, we just wouldn't have a clue whether to return a pointer or not. So I would probably default to a pointer just because I would think I'm bound to be writing some methods on this which are going to modify it. Does that help at all?
Yeah, it certainly made a little bit clear about when to use pointers and on.
I never think I explained this very well, but I comfort myself by thinking that if there was a brilliant, concise, compelling explanation of pointers in Go, somebody would have already said it, and therefore I could just copy and paste, and I don't think they have, or at least I don't know about it. But as with all of these things, it becomes a lot clearer as soon as you use it yourself, and you think, oh, I kind of see now why it has to be a pointer, but until then, just know that that's why we have the pointer there. So, alright, let's see what else we can find in this. So, Mike, perhaps would you read the next little bit for us? And let's read through this new bar, shall we? Let's see what that does.
Sure. We have a function that creates a new bar, returns a pointer to bar, as we discussed.
Right.
We have a variable that is set equal to the address of that bar, an empty bar struct literal. Then we do some initialization based configuration. Not quite sure what that is.
And we'll never know because there's no dot comment for it.
Sure.
Which is a shame, isn't it? And sometimes I see people that they've produced beautiful dot comments for all of their exported functions. You know, they're detailed, they explain what all the parameters are, everything the function does with them, and what all the return values mean, and in what situations it might return error, and what kind of errors it might return, and so forth. Wonderful. And it turns into beautiful auto-generated HTML on package.go.dev. And then for their internal or unexported functions, they just don't bother. Just think, well, presumably they're thinking, well, no one's going to be looking at those. But heads up, guys, we are looking,
Right.
and we have no idea what your method is about. So we're just going to have to look.
This is IDE fault. It doesn't say for me that's wrong. You know, there is no comment. So
I certainly think your IDE should nag you about stuff like that.
I'm just kidding.
Oh, I'm not.
Yeah,
So
when I was
go ahead, Tom.
when I was digging through this library, this is kind of the main thing that reason I was interested in it was because this was a pattern that I'd not seen in Go before. This kind of, you know, okay, I can see that when I create a new bar, I'm calling this method presumably on bar, but when I search the code base, that it is not, that it only exists on, you know, base configuration.
Yeah, right.
So, I mean, I could start to see the embedding. I didn't know that's what it was called or how it worked, but that was the only way it could possibly work, right? Was that somehow we were defining a thing in the struct that somehow got back to, you know, base configuration as a receiver method that I could call. But it's not obvious, because if you dig through if you start with rect chart, this init-based configuration does not exist on rect chart.
Yeah. Well, it doesn't exist on bar. Yeah, I mean, this is...
It doesn't exist on bar, yeah.
Yeah, I know exactly what you're saying. So it's, you know, you look at this and then you say, okay, I'm gonna call this method on my bar, but there is no such method. I can't find it anywhere. So, oh, there's an embedded rect chart. Maybe I'll look at that. Maybe it's a method on here. No, it isn't. Where the heck is that method? So maybe there's an embedded rect configuration inside that. So we're several levels of turtles down now. And if we look in here, oh, maybe it's a method on here. No, it's not. There's an embedded struct embedded within that, and then maybe if we go to that, maybe we'll find it here. Yes, we do. But that was quite a journey.
And, you know, now that I know how that works, it's not as if it's that bad to figure out. You know, my brain understands what, you know, how that functions. But it was kind of, you know, interesting to figure out at first.
Yeah, and I think that's kind of a clue that this is something you should avoid, isn't it? I mean, you know, if a perfectly competent Go programmer looks at some stuff and just says, I don't see how this works, then there's a problem, and it's not with the programmer. It's just because you can do something in Go doesn't mean you must do it, or even that you should do it. And in this kind of case, I don't think you should. There are cases where fields are embedded in structs, and one really common case is with a mutex. So if you have some struct which is going to be shared and a bunch of different Go routines are going to be accessing it, we're going to want a mutex on there probably to protect it. And you know, maybe you call it mutex, you know, and then somebody would be writing bar.mutex.lock, defer bar.mutex.unlock. But what they could do is just omit the name of the mutex, and they would just write sync.mutex, and then, you know, on your bar value you can just call bar.lock. Lock is actually a method on a mutex, here it is, and it will be promoted to the enclosing struct so that you can call lock on that struct and unlock. And that's nice because what you're really saying is lock the object, right? So Go lets you write exactly that, lock and unlock this struct. And that's probably one of the few defensible reasons to do it, I think. I don't know, what do you think?
I think some of it's style, right? I could see having worked in other programming languages, I could certainly see somebody looking at this and going, hey, I like this because it's a way for me to say a thing in Go that's not actually true, but it operates the way I want it to, which is that, hey, a rect or a bar is a rect chart, right? That's the way we want to say it, say in Java or something with, where we're gonna extend an object or something. We want to say, hey, I want bar to inherit all of the stuff from rect chart.
Yeah.
And to add on only what bar needs. So it's a pattern. I could see, again, I don't know that I necessarily agree in the case of Go, but I could certainly see somebody saying, hey, this is a pattern I want to have in Go.
Yeah. Yeah, I think that's right. And I mean, you can listen to me pontificate all day about Go style and what's good style and what's bad style, and there's no doubt that I'm right about all of that. But even I would admit, the ultimate rule is, does it allow me to write code that makes sense and is clear and readable and expresses what I want to say? I'm prepared to bend or break any rule to get to that. I'm hand-waving massively here because I didn't contribute to this library at all, and if I sat down to try to implement this, I might think, well, how am I going to do it? I don't want to embed fields because I told everybody on YouTube not to do that. And I might spend ages wrestling with it and find, you know what, all the other alternatives are just horrible. So I'm going to end up embedding it and saying, yeah, there are disadvantages to doing that because it's not clear to everybody and it can be hard to find where your behavior actually lives. But it's less bad than some of the other ways of doing it. And Go can be really restrictive about stuff like this, can't it? I mean, there are languages where you can create more or less whatever abstraction you want. Whether it's functional style or anything else. Go really isn't one of those languages, is it? It's very much, here's the way you're going to do it, and if you don't like it, other languages are available. So yeah, I think you're right, Tom. I think this is basically a sort of pushing the envelope of Go slightly in order to implement what is inherently a hierarchical class structure, which normally we wouldn't be able to do. So that's fine. Let's look at something different then. So should we look at a test? This will be interesting. So Quinn, perhaps I can prevail upon you to give us a bit of help here. If you wouldn't mind reading through this for us, and we'll just try and work out what's happening, shall we?
Okay. Which one? Just the test?
Yeah, let's see what's here, and we'll see what tests there are, and see if we can figure out what they do.
Okay.
Let's start with this one.
Okay, so the test bar asset for render. So we're making a new bar, and then we're seeing we're using Testify. Looks like.
Yeah. Our old friend Testify.
Yeah, we were just talking about this morning.
Yeah, and we talked about it on last week's Code Club as well, where I said don't use it. That's an oversimplification of what I said, but that's what it amounts to.
But we're just making sure that this JS assets values came from the new bar is equal to the stringer. Basically, that it has that charts in JS in there. It looks like.
That's right. So for anybody who hasn't seen Testify before, we have this assert.equal, which is really just the same as saying, you know, if we were using the standard library testing, we would have just written if x not equals y, right? Fail. This is another way to phrase that, is to say, assert that these two things I'm going to give you are equal, and if they're not, use this t object, which I'm going to pass you, to cause the test to fail. And you might perfectly well ask, well, why do I have to call assert.equal and import a whole library just to check if two things are equal? Because doesn't Go do that? Doesn't have an equals equals operator? And it sure does. And we probably wouldn't import testify just to check that one thing. But there are a bunch of nice things that it has. Assert no error and things like this, and especially when it comes to comparing more complicated values. There are some really useful helper methods in there, which save you just writing the same logic over and over again in different tests. So, you're absolutely right. We're asserting these two things are equal, so having created a new bar, there's some field on it.
Copy and paste save you that same trouble?
Yeah, that's the other way of doing it. And I definitely am not afraid of the copy and paste keys. You all know that. In fact, in general in Go, we're eager to repeat ourselves and duplicate code rather than creating some abstraction helper function. And now I have to write a bunch of stuff to package up all my arguments to that function, add logic inside it to handle the different kind of places they'll be called from, and then interpret the results in different ways. So we definitely wouldn't be afraid of that. And one thing we mentioned in the last Code Club about test frameworks is you've got to kind of be all in on them. You know, if you use Testify for one thing in one test, then you'd pretty much better use it for all your tests.
Right, you have to adopt the model and kind of, you know, we were just talking sort of, wondering about sort of how, like, you know, sort of using sort of the defaults, you get to sort of adapt and use your own patterns, but sort of when you use a framework, is kind of follow our model and our model and way of thinking about this, which could or could not align with what
Yeah. Then you have to learn the framework, which is going to take you some time as well. So, not really. I mean, it depends on who you are, but I don't find it an expedient way of learning Go. I find it now I'm learning frameworks in order to get the job done that I could probably use a standard package for. So.
Yeah, I think that's a good point. I mean, frameworks are great because they do a ton of the work for you. If you're here to learn, that may not actually be what you want. You may say, no, I actually prefer to build it myself so that I understand how it all works. And now I can sink into the warm embrace of the framework with a big sigh of relief saying, thank God I don't have to write all that code. But so yeah, so I personally don't use Testify or any other frameworks. I'm not dumping on Testify specifically, just generally. So I use the standard Go testing library for basically everything, and it works great for me. But I'm perfectly prepared to have someone come to me and say, yeah, you know what? For our code base or for our particular team, it makes total sense to use this framework because it does exactly what we want. And I would say, yep, that's fair enough.
I think from looking at it and other things with it is that one thing for Testify is that I think they have like other like libraries like stuff that makes mocking objects pretty easy.
Yeah.
As a sort of one reason to use it.
Yeah, that's right. The one thing I would say is maybe you don't need to do as much mocking as you might think, or you know, things where in other languages you'd instinctively reach and start constructing a mock. Maybe in Go there's other ways to do that, but certainly when you do have to do something like that, being able to just pull all of that code in as a well-designed, well-tested, widely used library that has lots of support is great, and the same goes for testing frameworks. So that's fine. So So the JS assets field is something which, again, is going to be embedded a few levels down inside bar. So we could guess, couldn't we, that because this is going to end up being a chart that we draw in an HTML page or whatever, that it's going to rely on some JavaScript assets to actually do things like the adorable animations. So I think what we're saying, Quinn, aren't we, is that having created a new bar, we should have the list of JS assets that it has should be exactly this.
Right.
And the min.js, I'm guessing, is probably that's probably the common code for all charts, isn't it? And then there'll be some extra JS for the specific thing that we're doing, maybe. Okay, I think that makes sense to us, doesn't it?
Mm-hmm.
That's a nice test. One thing we could have done, when we talk about things like assertions, we often say, I'm going to end up with some struct and I want to assert some things about it. Maybe I want to assert that this field is equal to a certain value, like this. And it can be convenient if you find yourself making a ton of assertions, if it's just literally line after line of assert equals so-and-so, maybe you might start to think, what if I just create the struct I want and then compare the two, right?
Yep.
You can just say here, there's going to be a whole bunch of stuff on it with a zillion embedded structs, and here's one that I carefully prepared earlier, which contains exactly everything I want, and I'm just going to say, is it literally equal to that? If not, I want to know. And that may not be convenient for you, because that may be a very complex struct, as we know it is, and you'd end up with just one test that compares, everything that can possibly happen with this complex expectation. And if that doesn't work, if the test fails, we have absolutely no idea which particular thing it is that failed. Maybe we're setting 75 struct fields, and even if we use gocomp and we use comp.diff to see only those fields which are different, it might still be obscure. So sometimes it's really useful to break things down into very specific tests that are just saying, yeah, I'm going to test other behaviors and other things other times, but for this one specific test, this is all I care about. I just want this JS library to be in there. So I think that's what's happening. Would you like to tackle the next one?
Sure. Here is test bar assets after render. So after we do rendering here, we create a new bar, then we run the render function.
Yeah, we don't know exactly what rendering is yet, but
right.
we can guess it's maybe producing HTML of itself.
Right.
Because
from OS standout.
Yeah, it took a writer,
Yeah.
and this is a pattern that often comes up, isn't it? That maybe you have some code that you want to write, which usually outputs to standard out or something. Maybe it just prints stuff, and then you start asking yourself, well, how can I test that? Because I can't read what showed up on the user's terminal. What I can do is inside that code I can say, don't just print to standard out, because maybe we're inside a test. Maybe we don't want to see any terminal output at all, but nonetheless, we want you to write something. What I'll do is I'll give you an io.writer. You write into that, and I'll do the rest. So in the test, we could create something which is an IO writer, but nonetheless doesn't print to the terminal, like a bytes buffer, for example. We could say, okay, here's an empty buffer, you write what you got to write, and then I'll look at it afterwards and say, did you write what I expected? In this case, the test actually just renders it to standard out. So, not really sure why they've done that.
Well, it looks like, it looks like they don't care about the actual output of the render, but the actual that we're looking at that JAssets values again, and then it should be. And now after rendering, I guess it looks like it should the host value. What is? I'm trying to figure out where that host comes from.
Yeah, I think you're absolutely right. So they're not interested in what it's actually rendering. Presumably, there's other tests for that. They're interested in what the state of it is afterwards. But given that they could have passed in any writer, and they're not going to look at it, so they don't care about the contents, I wouldn't have used standard out, because that will print output in amongst the test output, right? Which generally, if your test is passing, I don't want to see anything except the word OK. You know, I don't want to log a bunch of stuff. I don't want to print out things saying, got this far, got that far, here's what the data is. It just clutters things, and basically if every time you run your tests you get a screen full of clutter, it's real hard to distinguish the everything's okay clutter from the several tests failed clutter.
Right.
So I'm very much a keep your tests quiet kind of guy. And one, if you wanted to be able to pass in an IO writer which produces no visible output, there is one that does exactly that for you, and it's called ioutil.discard. So ioutil.discard is an IO writer, but it doesn't do anything. You can write to it, and that's perfectly fine. It just throws away everything that you write to it. It's like dev null on Unix. Yeah.
I see. I never knew this one. Nice.
Yeah, it's a useful little thing. There's a ton of these things in the standard library, which when you see it, you're kind of like, wow, I never knew that was there. This looks great. Why wasn't I informed?
Yeah.
So it's worth hunting around in there from time to time, because you're bound to find something cool. So, yeah, sorry, Quinn, I interrupted you.
Oh yeah, no.
Carry on.
Then that host is. I'm trying to figure out.
What is this host? Yeah. Oh, it's a constant.
Constant. Okay. So after rendering, it puts in that constant on the echarts.min there, and so it's looking for that to be in it after a render.
Okay, what do we think this is about?
May I just try?
Absolutely.
I think they are just comparing the value in the object, because like you won't be able to render the JS and test the output. So you are going to output the JS in the screen, which is meaningless. So I think they are just looking for if the URL like it's pointing to the right thing.
Yeah, well, if we're asking why would you need to prepend this URL to your assets, maybe if we think about it this way, so we're producing some HTML which you're going to serve from a web server, and it's going to reference certain assets like this JS, but how to find them? You know, what is the canonical URL to those assets? Well, we don't know with a brand new chart, but what we can say is if there's some URL where they're hosted, we don't want to embed that right deep down into the code, but we would like to put it somewhere, maybe as a constant here, so that we can reference it throughout the code, and then everything, you know, this part is just testing, do we have that specific JS library attached to the chart? And then, once we've rendered it, we say, did we render it in such a way that it had this URL in front of it? Does that sound reasonable? So, like, you know, yeah. So we could have just embedded that whole URL in here, but we didn't, because then it would be a pain to change for every one of the, I'm sure, 600 JS files that we're going to end up referencing.
Yeah. But I just don't get it. Why? Maybe I don't know enough about Testify, but why it would be a slice instead of string?
Well, it could be multiple strings. I think that's the point, isn't it? So JS assets implies there could be more than one asset. As it happens, there is only one, but the field itself must be a slice field so that it can hold multiple ones. So therefore, when we compare it, we have to compare it against a slice, which just happens to have one element.
Maybe there is assuming that at some point you can specify multiple JavaScript assets sort of to use, or like maybe sort of where they have some sort of validity or something.
Yeah, I think that's exactly right. So Tiago's question was, I think, basically, well, if there's only going to be one, why make it a slice field, right? Which is perfectly fair enough. But by making it a slice, they're giving themselves the option in the future to say, actually, yep, we're going to attach more things to this. Mm-hmm. So interestingly enough, they've done the comparison the opposite way around here, haven't they? So here we asserted that values was equal to this slice, and here they asserted that this slice was equal to values. So I think that's just a mistake, if you like, or not a mistake, but I think if they'd looked at both of these, they would have said, yeah, it's going to make sense to always do my comparisons in the same order.
Actually, I think before the rendering, you have just the URL there, and after you render the JS, you have the entire URL.
Yeah, absolutely. But what I mean is, when they're saying assert that these two things are equal, they asserted those two values in the opposite order, which makes no difference, of course. If they're equal, they're equal. Doesn't matter which comes first.
Yeah, but one has the host, the another, the first one doesn't have the host.
Yeah, absolutely. Yeah, these two expectations are different. That's quite right, because they're testing different things. But it's a great idea just to help people read your tests to always compare it in a fixed order. So like, in my tests it would be want and got, and I always say if want not equals got. I could have equally said if got not equals want, and of course the logic would be the same. But then what I'm going to do is I'm going to output comp.diff want and got, and then the order does matter, doesn't it? Because it's going to show you what it expected and what it actually got. And I need it to be that way round for the comparison, so therefore I'm going to do the test the same way round. So it's always want and got in that order. And here they could have done something similar.
Got you.
So that makes sense to me. So we're getting a bit short on time, but let's come to the end of it. So Rakesh, maybe you could help us with this last test, and we'll just walk through and see what's here.
Yeah, sure. They are creating a new bar here and assigning to bar. And then they're checking whether the rendering fails out to see if it errors out.
Yeah,
Here,
again we sort of incontinently dumped a bunch of stuff to stand it out, which no one wanted to see, but never mind.
And then they're trying to assert if there is an error first. It's good that they put that no error test first rather than the last. So if there is any error, the whole test suite can stop running.
Yeah, that's exactly right, because if there is an error, there's no point looking at anything else, is there? The presence of a non-nil error is a signal that everything else I gave you is useless. In fact, there wasn't anything in this particular case, but there could have been. So we always check the error first to say, did this even work? Because if it didn't, we better just fail now. There's no point going on and checking a bunch of stuff. Of course none of these things will be equal, because it didn't work. So that's why. And you know who I think Testify appeals to is people who don't like writing if not equals nil in Go, which I kind of feel if you don't like writing that, then maybe Go's not the language for you, because you will be writing it a lot, and editor snippets will help you here. But
The
That's
next
fine.
assertion they are trying to do whether the bar initialization width is exactly at 900 pixel, and similar to the height as well, they are checking whether it is initialized to 500 pixel.
Yeah.
Yeah, like Tiago was mentioning, yeah, they are hard coded. They could parameterize or sorry, create a constant.
Yeah, that's right. So the name of this test is giving us a clue that basically,
Or
you know, it's something that we face all the time when we're writing libraries. Is what there's bound to be some configuration, and the question is how much of that paperwork you want to put on the user if they're not particularly concerned about the configuration, right? If they just say, I just want whatever the default is, that'll be fine. So we probably want to set defaults. And we would like to do things in such a way that basically if you're not worried about the width, then you don't have to set it. What you don't want is the user sort of thinking, okay, I've created a bar chart, now how big should it be? If they already know the answer to that, then great, they can just set it. But if they're just thinking, well, I don't know if this is even going to work yet, let's just write some code and see what happens. So they can just create a new bar called bar.render, and that's it, they're done. And it will be 900 pixels.
Yeah, I
Which
agree,
is
but
probably fine.
my point is like they are thinking in the future, like they are using array, like not array, on slice of strings. But here they are using a string. What if they want to change the default value? They're going to change into different places.
Yeah. No, you're absolutely right. I wasn't disagreeing with that at all. I think that's dead right. Is whenever you have some initialization thing like this, you should probably define a constant somewhere, like
Like in the bar structure that has nothing,
yeah,
maybe.
yeah, and maybe the point being that number has to appear somewhere in your code. We're not disagreeing about that, but what we're saying is, should it be deeply buried inside several levels of structs or whatever, or should it be pulled out to a constant which we can put at the top of some file, or maybe just in a constants.go, so that anytime in the future, if you say, I need to tweak one of the magic numbers in my library, you know exactly where to go, don't you?
Yeah.
And I agree, I think that they would have done well to pull this out into a constant and say, when I create a new bar, is the width actually what my constant says it should be? Because you can guarantee, because you know that this must appear somewhere else, right? Somewhere else in this massive code base is going to be 900px, and then that's great until the day when someone decides, you know what, it should be 1000.
Yeah.
And now all the tests will break for no good reason. Fragile tests is what we're creating here. So yeah, go ahead, Rakesh.
yeah, here I have one question. It's more of a preference. Here earlier in line number 27, we find that giving no error test case there, it helped us stop running the test cases altogether if there is an error. But
I assume so.
given if this test case is fast, but it failed at 28 and it is going to fail at 29 as well, if we stop at 28 and see this error as a red for this test case, and then we go and fix, and then we need to go run again, and then we'll fail at 29 again, and then we'll fix it, and then go in 30. Would it be nice Go still runs all the other test cases, and then we fix all the test cases in one go? Or is it like a preference?
I know what you're going to say now, teacher.
I'm not sure I do. Well, yeah, no, if I understand you right, Rakesh, you're saying if one of these assertions fails, what happens? Does it just stop the test there, or does it carry on with all of the other things maybe failing as well? Well, that's not sure what testify does, but if we were using the standard library testing, we would be talking about the difference between t.error and t.fatal, wouldn't we?
Yeah.
Is if we said t.error, we're saying, yeah, that's an error, but I'm going to carry on with the rest of the test and see what else is wrong. Or if we say t.fatal, we say, no, 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 something's gone so badly wrong that I know it's not even worth executing the rest of the test. Like maybe one of our test fixtures broke, or, you know, or we couldn't open some file that we needed to, or we got an unexpected error from here or something. So basically bail out. So I don't know the answer about Testify. I'm sure someone else does, but we can find out, can't we? It would be nice if you could do both, wouldn't it?
Yeah.
If you have the choice, rather, to say, you know, assert that these things are equal, but if they're not, you know, that's cool. We'll still carry on. Or maybe I'm asserting it so vociferously that I want to bail out of the test if it's not true.
Sure. Fatal type of errors for line number 27 and normal errors for 28 and 29. So we can fix all at one go, or like at least 4 or 5 errors in one go.
Yeah, I think so. And it's you know, when you're writing tests, regardless of what library you're using, it's a choice for you, isn't it? That you might say, I want to, you know, like you could imagine this function could be wrong in such a way that when you run it, this assertion fails, and you go, oh right, I've got a bug. Okay, I'll go fix it. Run the test again. Oh, this time the next one fails. All right, fix that one. Go back, run it again. This time the next one fails. Like, I'm getting a bit tired of going around this loop. Yeah. What I really wanted was just to see all 4 things that are wrong. I'll go fix them all, and then we're good. So that's when you'd be making that decision about error versus fatal.
Yeah, so the equals it is a fatal error in Testify.
Is it? Right.
Yeah, you have a error method too, which just return an error. Does the same thing.
Oh, so assert. Wait, did you say it was error?
Yeah.
Assert.error, is that right?
Yeah.
And then you give it 2 things, and if they're not equal, that's a non-fatal test failure.
Yes, I can, as far as...
That seems weird, because you've got assert no error, and you give it an error, so I would have expected that assert error is the same but with the opposite sense.
Oh no, it's not what error does. But to have a bunch of assert functions here, you have like hundreds of assert.
Yeah, what we want is maybe something like assert equal, but I'm not too bothered about it.
You have equal error. Let me see if this one.
Or maybe instead of the word assert, you know, it could be a less less emphatic verb like suggest.
Yeah.
Suggest dot equal, or maybe dot equal. That's a fun project for someone right there. Okay, I think we better wrap up, because we're out of time, but this has been a very fun session, and thanks very much to everybody.
Thank you for organizing this.
My pleasure. All right.
Thank you.
Bye, everybody.
Bye.
Bye.